So, good day. I am Ryan Paguia, a BSECE 3A student. In this video, we are going to talk about flip-flops. T-flip-flop to be specific. Flip-flops are sequential logic devices which have a form of memory built in. Flip-flops are bistable devices, meaning their inputs and outputs can be one of the two states, a logic level 0 or a logic level 1. Flip-flop has different types. The SR flip-flop, the D flip-flop, JK flip-flop, and the T flip-flop. T flip-flop. It is also known as toggle flip-flop. It is used to provide only one input to the flip-flop called trigger input or toggle input T. Then the flip-flop acts as a toggle switch, which means changing the next state output to complement of the present state output. Now, this is the logic symbol of T flip-flop. It has one toggle input T and one clock signal input or CLK. We have also the output and the inverted output. And this is now the truth table. We have here the input and the output is divided into two. The present state and the next state. We have here the T input, a QN and a Q next. Okay. So, if our input T is low, or that is T equals 0, then the present state and the next state is always the same. For example, the present state is 0, then the next state will be also 0. If 1, then 1. On the other hand, if the input T is high or 1, the present state is always opposite to the next state. Example, if present state is 0, the next state will be 1. Present state is 1, then the next state will be 0. From the truth table, characteristic equation can be derived. Q next is equal to the sum of T multiplied by Q prime and T prime multiplied by Q. If we substitute 0 to T, then we get Q. And if we substitute 1 to T, then we have the Q prime. The simplest way to construct a T flip-flop is with JK flip-flop. The J and K input of the JK flip-flop are connected together provided with a T input. Similarly, a T flip-flop can also be constructed by SR flip-flop made of NAND logic gates. We have here the toggle input T. It is connected to the NAND gates as an input, and these NAND gates are also connected with common clock CLK signal over here. We know that a T flip-flop is an edge trigger device. For example, if the output here is 0 and that's Q equals 0, then the NAND over here is in enable state. This allows the trigger to pass the S inputs to make the flip-flop in set state having Q equals 1, while the NAND over here is in disable. In contrast, if the output here is Q equals 1, then the NAND here is in enable state, allowing the trigger to pass the R inputs to make the flip-flop in reset state having Q equals 0, while the NAND here is in disable. All in all, when we go back to this table, we can see the operation of the T flip-flop. When the T input is low, and that is 0, Then the next state of the T flip-flop, is always the same as the present state. Just like here. T equals 0 and present state equals 0, then the next state must be equals 0. T equals 0, present state equals 1, then the next state is also equal to 1. In addition to this, when the T input is high or 1, that's during the positive transition of the clock signal, the next state of the T flip-flop is exactly the opposite of present state. Just like here, we have 0. In the next state, it is 1. In the present state is 1, and the next state is 0. So we have here now the actual logic circuits used for creating a T flip-flop using the electronic workbench. As what we have discussed earlier, this is the equivalent logic circuit for the T flip-flop, which is also derived from the other flip-flop, JK flip-flop, and it is composed of 2 input NAND gates and 3 input NAND gates. You may also notice that this is a master-slave JK flip-flop. Then we have these two another component, which is the preset and the clear. So let's now demonstrate the operation of this flip-flop. If we start to run the simulation, we can see the indicator for the output Q and Q prime are blinking. This only means that this is running and making this T flip-flop ready to respond to the value of toggled input and the clock input. This condition happens when the preset here is equal to clear, and that's 1. Then the clock input can take place. Now, if we set the value of the preset to 0, 3, and the clear will be 1, we can see that the preset is activated, and so the Q is set to 1, not depending in other conditions. While the preset is equal to 0, the clock inputs here cannot take place, just like this, only in the inverted output Q prime is blinking. This also goes the same if we set the preset to 1 and the clear is to 0. The clear is activated, so Q is also cleared to 0, not also depending on the conditions of the other inputs. Then the clock input here has no effect if clear is equal to 0. Another condition is when we set the value of both preset and clear equal to 0. We can see the result as invalid or must not happen, because we know in the first place that these two outputs must not have the same output. As it says that Q is the output and Q prime is the inverted output. And this is now the output waveform for the T flip-flop. That's it. And that's all. Thank you for watching.